Today, we'll take you through the development process of aircraft propulsion, the early years of the development in which the various kinds of propulsive devices were thought of. Some of them were actually created as some kind of a prototype, but many of them never quite flew, and we will go on to the Wright brothers when the aircraft flew for the first time, and what happened thereafter, how the aircraft engines actually developed over a period of almost 150 years. The first aircraft that flew was nearly 150 years back, that did not fly actually, but was created nearly about 150 years back. One of the creations was by Felix du Temple de la Croix, who had what was called a monoplane at that time, and the early ideas were those that resembled that of a bird. This particular picture, as you can see here, it has wings very much like a bird, a tail plane that resembles that of a bird, and this is the body in which somebody or some things could be placed. You can see the tail again that resembles that of a bird, and the side view which resembles almost that of a boat in which something or somebody could probably sit or be placed over there. And then of course, you see the propeller. This is the concept that was created nearly 150 years back, that to fly a craft like this through the air, you would need a propeller like device to make it move in air. And this is a side view of the propeller, which gives the first impression of what mankind thought a flight craft could possibly be, and this was nearly 150 years back. The idea that you need to have thrust created by some kind of a propulsor was created around that time, and it required that if an aircraft is flying, the craft, by studying the birds and many other such flying objects, people realized that you need to create lift, and the idea at that time was that you create lift by designing a particular kind of aircraft that typically would resemble something like a bird or one kind of bird or the other. However, to do that you need a certain amount of force to overcome what is also known as drag, and this is due to the resistance of the air in which the craft flies. Now, when the craft is flying, this resistance is continuously active on the body of the craft, and this resistance of course, also would change a little depending on the mode of flight. And during these various modes of flight, you need to create thrust that on a continuous basis overcomes this resistance or air resistance, and keeps the craft flying at certain predetermined speeds in a certain predetermined mode, and this creates finally the aircraft motion. Now, unless you have these balance of forces, the lift which should overcome the weight of the craft, and a thrust created by a propulsor which on a continuous basis must overcome the drag, it is not possible to fly. This is the minimum requirement for a craft to fly, and our business in this course is to look at how the thrust is created by propulsor, which propels the aircraft through the air, and various kinds of engines that create the propulsive power that finally creates the thrust. The early few devices that were created, but were in the designer's drawing board. One of them was by George Cayley. Now, George Cayley is quite often credited with being the father of modern aeronautics, and he created much of the science that is used even today for understanding the aircraft flight. And what he created was a craft that looks something like this, okay, and it had a small boat again and a big wing which helps the creation of the lift, and then again a tail plane that is necessary like a bird to balance the flight. Now, this is what something like this is what he conceived at the time of creating the science of aeronautics, which is laid down in many books even today. A little later after that, a gentleman called Samuel P. Langley created another kind of craft. Now, this had two wings, one above the other, and is often referred to as a biplane, as opposed to the first one, which is often referred to as a monoplane. Now, monoplane had one wing on each side, so two wings on two sides. This had four wings, so two on each side in a symmetric manner, and this was a little later in late 19th century. And this was what first attempt to create something that could possibly fly. One of the reasons one supposes that you need two wings was to create sufficient lift to make the craft balance the weight, and to do that they had to create two sets of wings on each side, and as a result of which you could also see there are two sets of tail planes at the rear, which is not exactly what the birds do, but at that point of time people had realized that you can't have a craft which exactly looks like a bird. You need to create something different, and that difference is what appeared as biplane. Now, Samuel Langley's biplane was attempted to be flown. However, this particular attempt, this picture shows that the first attempt at this flight was unsuccessful, and as soon as the craft took off from a ramp on a water body, it immediately thereafter crashed onto the air body. One of the reasons possibly was that the power available was not sufficient for the craft to balance its drag in the air. As a result of which, a lot of people looked at various kinds of powering device, the device that would finally propel the craft through the air and provide sufficient power on a continuous basis. Now, this required them to look at creating engines that would drive the propeller. By that time, it was known that you have to have a propeller to make an aircraft move in air. The question was, what kind of engine do you require to make the propeller create sufficient thrust? Now, one of the first attempt was by Loren, and he created what can be called kind of a jet engine, but it was based on the piston engine concept, which was prevailing at that time and had already appeared in market. And this means that a piston would be moving like this and would expel the gas, as you know, probably every second stroke, and as a result of which this gas being expelled or ejected would create a kind of a jet action, which again, as per Newton's third law, which we studied in the last class, would give a reaction and provide the thrust, which means that you would get a thrust every second stroke of this piston. This was the concept created by Loren, and as a result of that, Loren, what he did, he quickly realized that a single piston quite often would not be sufficient to create sufficient thrust, and hence he lined up 6 of them one after another in line, so that 6 of them could produce thrust. Also, there is a possibility that he could time the piston stroke such that they do not actually eject the hot gas simultaneously. It could be timed to eject them in a manner, so that only 2 of them eject at one time, or it could be timed in a manner that all 6 of them eject at the same time, depending on the amount of thrust that needs to be created. This engine, of course, was a concept. It was never made and certainly never flew. The next patent that Loren actually went for was a little more simplistic, and he went for a straightforward what we call jet engine, in which the air enters the chamber, and then there is a fuel burning that happens over here, and then the hot gas is expelled through a nozzle and through in a jet. And this again, as per Newton's third law, creates the reaction that would hopefully propel the aircraft through the air. So, this was a concept created by Wright in 1913, for which he actually took a patent. Now, thereafter, little thereafter, there was another concept of jet engine. This was in 1921, and around this time a gentleman called Guillaume patented a concept which supposedly looks like a jet engine. It has a concept very similar to present jet engines, which we will look at in detail a little later. It had compressors and then it had turbines, and as a result of which it is supposed to create a jet thrust. However, as far as all the records go, this kind of engine was never quite materialized and certainly never flew. The one engine that definitely flew and created the so called history of the first flight was the Wright's engine. Now, this engine was again quite simple. It had 4 cylinders, and these 4 cylinders actually powered one particular shaft, and this shaft powered the propeller, which flew the Wright brothers plane simply called Flyer. And this is the details of one of those pistons, which has all the components, and those who are familiar with the typical piston engine would find all the components of the piston engine over here. You have the air intake, and you have the intake manifold, and then you have the combustion chamber, etc. All the components that one is familiar with, you would find this here. This was a standard piston engine, and what they did, they had enough calculation to back them up, and they realized that you need a minimum of 4 engines to create sufficient power to power their propeller, and this is what they had put on their craft, which flew for the first time in 1903. Now, this was the craft. This is a historic photograph which some of you may have seen, and this shows that the Wright brothers flying for the first time in the history of mankind in a beach called Kitty Hawk in North Carolina, USA. And this is the flight in which Orville Wright was flying, and Wilbur Wright was standing over here. On the same day in the morning, they flew 4 times, one after another, each brother taking his turn, and out of the 4, 3 of the flights are recorded as the first 3 flights of the human kind. Now, this had the engine which we just seen, and it had the propellers which we will have a look at. Now, this is the craft which is been preserved in a museum in Washington DC, the Smithsonian Institute Museum, and if you people go there, you would be able to see the craft hanging over there even today. As you can see here, it was a biplane, as we were discussing. It had 2 wings, okay, and it had 2 tail planes. In fact, they were in front, and you could see here a person actually lying down. So, Orville Wright was actually lying down on the aircraft, because there was nearly no place for him to sit there. Okay. And this, you can see the craft from another picture, in which the 2 wings are very clearly seen, and the 2 tail planes are also seen. As we have discussed, this was part of the aircraft design, which Wright brothers took a long time to perfect before actually they flew. And then now you can see the propellers which they used in the 1903 flight, and the propellers they used later on, a little later, around 1910. And over the years, the shape of the propeller which they used actually changed a lot. The propeller you can see here is it's a simpler propeller. It's a paddle type. Here the propeller, as you can see, 1910 is a little more twisted, far more twisted, bigger in size, and probably has much better shape for creation of thrust. So, there was evolution of propeller even with the Wright brothers over a period of 7-10 years, in which they were involved in the various kinds of flying crafts. There is a historical claim made by a gentleman called Gustav Whitehead that 2 years, 4 months and 3 days before the successful flight of the Wright brothers, a monoplane actually took to the air on August 14, 1901. That is nearly 2.5 years before the Wright brothers flight. Somewhere in US, in Connecticut, carrying, and it was carrying its inventor Gustav Whitehead, and it is reported to have flown by about half a mile, which would be far more than what the Wright brothers flew. What the Wright brothers flew, for example, in its flight was the distance which is now recorded as equivalent to the wingspan of today's Boeing 747. So, it was a very small hop, so to say, but the flight claimed by Gustav Whitehead or his successors later on claims to have been a flight of nearly half a mile. There is no record except for this particular picture. It was supposed to be a monoplane resembling that of a same picture that we have seen for Felix de Timple's monoplane. So, somewhere 50 years after Felix de Timple's monoplane, somebody, a gentleman named Gustav Whitehead, is reported to have created a similar monoplane and actually flew it. However, this has not been scientifically accepted, and as far as all the historical scientific records are concerned, the first flight is credited to the Wright brothers. And what we see now is that all the flights that were recorded over a period of first 50 years of flight all flew with propellers as the only means of propulsion, which means that jet engine as we know today were not the means through which propulsion was done. It was propellers all the way for over a period of half a century. In fact, according to the records in various scientific recording manuals, sometime after World War I, a high powered committee in US went into the decision making whether jet propulsion could be used for various kinds of flights, and they came with the decision that jet propulsion was really not possible within the foreseeable future, and hence they entrusted NACA, that is the National Administration of Civil Aviation, which created this, which was created in US with the creation of a large number of propeller blades. And these propeller blades were created by NACA in between the two world wars. As we shall see later on, by the Second World War, jet propulsion had actually come into being, and the prediction made by the so called high powered body had proved to be erroneous. We will come to that in a few minutes. Let us go through the development of propellers. Now, propellers, what they do is they use airfoil shapes. Now, airfoil shapes were created, as we have seen, as we know, by George Cayley nearly 150 years back, and it was proven that many of the birds and fishes do have these kind of airfoil shapes that allow them to move through the air or water in case of fishes very smoothly. So, that shape is what today we call airfoil shape, and this is what is used in the propellers also. Propeller uses the shapes, and as the propellers rotate, as per the shape characteristics, they create lift, and a component of the lift is then utilized as thrust. Now, this thrust is created in a direction which is perpendicular to the plane of rotation of the propeller, and this is to be designed into the propeller. So, it is necessary that person who designs a propeller for a particular aircraft is knowledgeable about the science of a propeller, so that when he creates a propeller for a particular aircraft, the propulsive action is created exactly perpendicular to the plane of rotation that meets the demand of that particular aircraft. Propellers can be broadly in two types. One that pulls the aircraft from the front, that is its position at the front of the aircraft, either at the nose of the aircraft or mounted on the wings at the front of the wings, and these are called tractor type propellers. There are the other types where sometimes the propellers could be mounted on the rear of the aircraft, which could be at the rear of the fuselage or body of the aircraft, or at the back of the wings, and it could actually create thrust from the rear of these bodies, and they are called the pusher type, as if they are pushing the aircraft from the rear. So, these are the two kinds of propellers that have been around for quite a long time. Most of the propellers that we see are the tractor types, but there are quite a few pusher type propellers that have also been used over a period of last 100 years. These are the various propeller blade aerofoil shapes created by NACA more than 60 years back. As you can see, these shapes are so many, there are more than 100 shapes over here, and they have served the purpose of creation of literally hundreds and thousands of propellers that fly various aircraft around the world. So, this was the basis or the beginning of creation of propellers. There are a number of companies who are specialized in using these aerofoil shapes for creating the propellers. Let us quickly take a look at how the propeller actually operates, because that is what made the aircraft fly for nearly half a century. In fact, propellers are being used even today for flying many aircraft. So, the history of propellers flying the aircraft is more than 100 years old, and they are still active in flying many aircraft. So, let us take a quick look what the propellers actually do. The propellers actually, if you look at the picture over here, they are mounted, let us say some are at the nose over here, which is what we would call a tractor type of a propeller, and by virtue of its rotation and the aerofoil shape that is given to it, it actually sucks the flow from the front and then it pushes it behind. Okay. So, this suction of the air is aided by the motion of the aircraft. So, as soon as the aircraft starts moving, the motion of the aircraft allows the air to move into the propeller, and as the propeller rotates, it also applies the suction. So, when the aircraft is moving in air, the suction of the propeller is expected to match the motion of the aircraft, so that the amount of air that is going through the propeller is actually matched between the propeller and the aircraft movement. Now, when that happens, the flow through the propeller then goes through let us say a disc like this, which is what we would call the swept area of the propeller, and then as it goes through, it acquires a little bit of extra energy or extra momentum. This momentum difference, as we know from Newton's second law, provides the thrust. So, this is the momentum of the jet that is being pushed by the propeller. This is the momentum of the air that is coming into the propeller, and this provides the thrust that makes the aircraft move. This thrust must balance the drag that is experienced by this entire aircraft. So, this propeller matches the entire drag created by this entire, including the drag of the engine and the propeller itself. So, it is the only thrusting body mounted on an aircraft. If you look at a typical propeller, this is a typical propeller, it would look something like this. There are various kinds of propellers, various shapes. We will probably have a chance to go into it later on in this course, but in this particular diagram, as you can see, there is propeller shape, which this is the tip of the propeller, okay, which is what you would see somewhere over here, and this is the root of the propeller, which is at the core of the propeller and is connected to the shaft, which comes out of the engine, okay, and this shaft goes inside over here, and quite often this shaft is covered by a nice what is known as a nose cone to make it aerodynamically smooth, and that is in front of the propeller. So, flow goes over the nose cone and then enters through the root and then flows over the body of the aircraft. Now, if you take a cross section of the propeller over here, just anywhere, you would probably see a shape like this, and this is the airfoil shape. And as we have seen, there are so many kinds of aerofoil, so many shapes of aerofoil that could be used. Typically, in one single propeller, all the way from here to here, we would call this, let us say, the working part of the propeller, which creates the thrust. You could probably see various propeller aerofoil shapes. So, the aerofoils that are used in a propeller from root to the tip of the propeller actually change. There are various kinds of aerofoils. So, propeller near the root typically would be a thick propeller, whereas the propeller near the tip would typically be a very thin propeller. Let us take a quick look. Some of the thick propellers aerofoils that you see here are likely to be used near the roots. So, this is how typically you probably have a root propeller here, and then slowly they become thinner, and as you go toward the tip, you would probably have a thin aerofoil like this. So, one such set, each such set probably could serve the purpose of one propeller, and that is how the propellers are utilized. Aerofoils are utilized in a propeller for creating the thrust. These are the various kinds of propellers that you would probably see today. If you go around, this is, for example, a propeller that is after it is being made, the propeller needs to be proven, and one of the means of proving it is to actually test it in a wind tunnel. A wind tunnel actually is just a land based grounded facility in which various bodies can be put for aerodynamic testing, and propeller is also one such element that can be tested inside a wind tunnel. And inside the wind tunnel, you test the aerodynamic capability of the propeller, you measure the thrust that it is creating, and as I have mentioned before, it is necessary that you have exact estimate of the thrust that the propeller would create, because when the aircraft is flying in air, the exact matching is an absolute necessity. If there is any mismatching, remember, the aircraft is not going to fly. If the thrust falls short of the drag, the aircraft is going to fall, and if there is any passenger, they are going to be hurt or they are going to be killed. So, it is absolutely necessary that the thrust of the propeller is very accurately predetermined even before it has flown. You can see here a propeller. Now, this is a propeller where you can see here you have 4 blades. Now, this is a propeller where you can see you have 3 blades. So, many of the propellers that fly quite often have 3 blades. Now, this is a tractor type of propeller where the propeller is at the nose of the aircraft, in front of the aircraft. This is an aircraft in which the propeller is the rear and what we call the pusher kind of a propeller. So, it is at the rear of the propeller, at the tail of the aircraft, and this is a typical design in which it was thought that putting the propeller at the nose may not be an appropriate thing to do for this particular design, whereas this particular aircraft design accommodates the propeller right at the nose, and it is a tractor type of a propeller. Now, to run a propeller, you need engines. As we have seen 100 years back, the kind of engines that everybody was familiar with were the piston engines, which were already powering the automobiles and other vehicles moving on the surface of the earth. They were also powering various kinds of engines that powered the boats that went over the waters. Now, this kind of engine had certain specific requirements. To make an engine that will go inside an aircraft and will fly with the aircraft, needed that they should be very light, they should create sufficient power to power the propeller, which should create thrust to fly the aircraft, And one of the prime requirements of anything that goes on aircraft, that it has to be light and it has to be very compact and very small in size. Now, this was a requirement that was specific to the aircraft engines, and as a result of which the engine arrangement needed to be looked into. So, what people did, they looked at various kinds of arrangements. If you have pistons, let us say, lined up one after another, in line, those are simply called inline engines. All these pistons would drive one single shaft over here, and this is your piston drive. So, the piston movement could be timed such that there is a continuous power supply to the shaft, which of course drives the propeller. The other way of doing it is what is known as the opposed cylinder. That means, instead of having all the pistons on one side and lining them up one after another to get certain amount of aggregate power, you have, let us say, two pistons or two cylinders on two sides, powering a central shaft. So, you have two pistons on two sides, and they are timed in such a manner that the power stroke of the two are staggered in time. Another variant of this is to have opposed piston within, let us say, one body of a cylinder. So, you have two pistons, and it is actually powering on two shafts, one on this side, one on that side. Quite often we shall see later on that they would go on to power a single propeller. The other arrangement which people came up with is simply called the V type, where the pistons are arranged in a V formation, and they again power the central shaft over here. In this V formation, you can again put them in line like this single engine. So, you can have V engines lined up one after another or one behind the other, and so you could, for example, have two engines in V formation, or you can have 4 engines, you can have 6 engines, you can have 8 engines, or you can have 12 engines lined up in line in V formation. Many of the modern aircraft do actually have up to 12 engines lined up to supply the aggregate power to run the propeller. The other way of looking at power generation is to have, let us say, X type, where you have 4 of these pistons powering a central shaft, and again the timing of the 4 pistons are such that this central shaft is continuously being supplied with power, and which runs the propeller. So, you can have 4 of them now lined up, and then you can have 4 and then 4 engines doubled up, you can have 8 of them lined up, creating power to run the propeller. If you have more than 4, one of the ways of doing is to have a radial arrangement, so that you can arrange them around in a circular formation. You can have 5 of them, typically you can have 7 of them or 9 of them, and then you can again double them up. That means, you can have 2 sets in line with each other. So, instead of a single piston, you can have radial arrangement in line, at least 2 sets in line, so that you can have total of 10 cylinders or 14 cylinders or 18 cylinders powering one single central shaft. The other arrangement is also simply known as H type, which again uses 4 cylinders, and this time it is trying to power 2 shafts to create power that is supplied to the propeller. These multi-cylinder arrangements for aircraft propulsion were created essentially to go into the aircraft. The various cylindrical arrangements that we are looking at were created essentially for the aircraft power plants. Now, as we have seen in the earlier pictures, these aircrafts have shapes. These shapes are created by the aircraft designer to create lift, to create minimum drag, and of course, to house a passenger or passengers to fly in the aircraft. Now, once you create this shape that is supposed to create minimum amount of drag, your engine needs to be somehow accommodated within this shape. This is the important issue, that your engine arrangement must conform to the shape of the aircraft that has been created. So, various kinds of engine arrangements were created to go inside these shapes. For example, this tractor type of propeller, it has a shape of the front of the body, inside which one can guess the engine is housed. We can only see the propeller here, and this engine must have a certain amount of space in a certain shape, and that shape is likely to be let us say accommodated by something like this or something like this. Okay. That particular aircraft is most unlikely to have a radial kind of an engine. The shape of the aircraft here does not quite throw any promise of accommodating a radial kind of engine. So, those are the various issues that govern the choice of the arrangement of engines and the kind of engine shape or arrangement that would be finally selected for aircraft. The number of cylinders is decided by the kind of power that is required, the amount of power that is required, and this is to be decided by the thrust that is required by the aircraft. So, to accommodate the aggregate power that is required, the number of cylinders can be increased. So, number of cylinders is decided by the thrust power that has to be delivered by the powering propeller. These are the pictures of the various arrangement that we were talking about. This is typically an inline engine. As you can see now, they have been created in a shape that could, in a very compact shape, that could now go inside an aircraft, and you could have your propeller mounted over here. And this is the opposed cylinder type, where you have two over here and two on the other side, and this is where your shaft is coming out, which is the central shaft powered by all the cylinders, and this would power your propeller. This is the V type, where you can see one cylinder here and other on the other side, and you have so many of them lined up, okay, and they power the central shaft, which is coming out over here, okay, and that runs the propeller. So, this is the arrangement which typically would go inside an aircraft and conforming to the aircraft streamlined shape, the low drag shape. This is a radial kind of propeller. As you can see here, there are so many of them mounted in a radial formation, and they have the central shaft, and you can see here the propeller actually fixed to the engine. So, these are the various kinds of arrangements that have been used over the years. For example, these are the ones you are likely to see in small aircraft. These the upper two you are more likely to see in the small aircraft, which probably fly 2 people or not more than 4 people, whereas the lower ones you would probably see powering aircraft which fly maybe 6 people or 8 people, and radial engine which accommodates more cylinders, which means more power, would typically be used for aircraft which fly more people, something like 10-12 people in one aircraft. Then we look at the various kinds of jet propulsion devices as have been used in last 60 years or so. The first jet engine that is recorded to have flown actually is the Henkel engine, created by Ohain in Germany. However, Henkel engine is not the first recorded jet engine. That credit goes to is given now to Frank Whittle, even though historically it is pretty much understood that the creation of Henkel engine by von Ohain and that by Frank Whittle in England, von Ohain in Germany, were going on simultaneously, independent of each other, and they came out with the engines almost simultaneously in their respective countries. The Henkel engine flew for the first time on an aircraft. Whittle's engine actually flew a little later. This is the Whittle's engine which he patented. You can see here that he had all his concepts in place. It was based on a thermodynamic concept of cycle, and it is a heat engine. So, it is supposed to conform to a known cycle, and he already had the idea that what kind of cycle he would use. These are the details of the engine, in which he used axial compressor, he used a centrifugal compressor, which then supplied the air to the combustion chamber, which drove an axial flow turbine, which in turn drives the compressors, and then you have the jet over here, which or exit nozzle, which is supposed to finally go out in a big jet to create the thrust. So, this is the conceptual design which Frank Whittle finally patented and was granted the patent, and that was supposed to be the historically the first patent granted for a jet engine. The kind of aircraft power plant that we have today, there are many of them. We have just seen that the early 50 years, most of the aircraft were flown with what is known as piston props. That means, the piston engines powering propellers. Now, as soon as the jet engines came in, one of the varieties that immediately sprang up was what we today known as turboprops. That means, these were the jet engines, but they were powering the propellers. That means, the jet thrust that was available was not the main thrust making device, but it is a propeller which creates the main thrust. However, immediately thereafter, the actual pure jet engine started coming, and this is the thrust characteristic of these three basic kind of engines, all three of which are in operation even today. And as you can see here, as the flight Mach number increases from 0 to let us say 0.75, which are still subsonic flights, the effectivity of the turboprops or the piston props or the propellers start going down, and somewhere around Mach 0.5, the effectivity of the propellers have gone down to the level that the turbojets become more and more effective means of powering an aircraft. This was realized more than 50 years back, and people wanted to fly higher, they wanted to fly faster, and when flight of Mach 0.5 became imminent immediately after the World War II, most of the aircraft designers started looking for jet engines that would give them the necessary power to fly the aircraft at high speeds. Now, some of these are known today, and as a result of which, most of the flight today at a higher flight Mach numbers are powered by jet engines. Most of the flights even today at lower flights Mach numbers are indeed still powered by propeller driven power plants. So, there is a clear divide here. At low speed, you would probably like to go with a propeller driven power plant. At high speed, you would probably invariably look for a pure jet engine or a turbojet engine to power your aircraft. If one stretches a little more with the use of what is known as propulsive efficiency, which is actually a measure of the end usage of the available energy for final thrust creation. It is not same as thermal efficiency or the overall efficiency of an engine as determined from the thermodynamics. This is the propulsive efficiency, that is how much of energy that is available at the end of the engine action that is finally converted to thrust. All the energy that is available for thrust making does not finally create thrust. So, this propulsive efficiency is the measure of the or efficiency of the end use of the available energy. Now, this provides a quick glimpse of what happens to various kinds of engines. The turboprop, the efficiency can be very high at low flight Mach numbers. It peaks at somewhere around Mach 0.4 or 0.5, and then it starts dropping very fast. Okay. And then if you look at the jet engines and its variants, the turbofan engines, they start rising, and from flight Mach number 0.5 onwards, they become competitive. The modern variant of the propeller, which is some kind of a mix between propeller and fan, is called prop fan, and this prop fan extends the propeller utility a little more up to say Mach 0.75 or 0.8 and keeps it in a competitive market, after which again the turbofans and the turbojets would need to be used to power the aircraft. So, these are pretty much known today, that if you have pure propeller, your effectivity or efficiency would start growing down very fast indeed, around Mach 0.5, and with the modern prop fans, we will have a quick look at it today. You can extend it to around 0.75, but thereafter inevitably its efficiency would start going down. And one of the reasons the propellers suffer from the efficiency defect is because the flow over the propellers, we have seen they are made of airfoils, the flow of the airfoils do become supersonic. The airfoils that are used in propellers cannot negotiate those supersonic flows in rotating formation, and as a result of which the efficiency starts dropping due to the appearance of the shock waves due to the supersonic flow. In the prop fans that are used in the modern aircraft, and you would probably see more and more of them in the years to come, some of the supersonic flow is being accommodated, a low supersonic flow has been accommodated, but even today a high supersonic flow or clear supersonic flows cannot be accommodated through the rotating propellers, and as a result of which the efficiency drop starts appearing, and hence you would need to use a variety of jet engine, either pure jet or turbojet, to power your aircraft. The use of prop fans, and also called prop jets, extend the use of the propellers to high Mach numbers, and this extension has been possible by redesigning the propellers with new kind of aerofoils. When we go to the propeller chapter, we will probably have a look at those aerofoils, what allows them to negotiate higher Mach numbers as they are flowing over the propeller blades, which, as I mentioned, could actually go supersonic. As a result of which, the jet propulsion became more and more important, specifically after the World War II, and today one of the prime means of aircraft flying around the world is the jet propulsion, which we will look at more in the next class. Let us take a quick look at the fundamental issues that we are bothered with here. The thrust generation, as we have seen, is by using the Newton's second law, and this creates the thrust, which is finally equated to the mass of air and the acceleration. We can now rewrite that as mass flow and change of velocity, and this is the mass flow that we have. Now, this mass flow, if it is very high and the change of velocity is indeed very small, what we have are what we call propellers. A very high mass of activation is what the propellers do with a very small change in velocity. On the other hand, a very large change of momentum or acceleration is created by the jet engines, which actually operate with a very low mass of activation. So, very small mass is activated through a large change of momentum is what is jet engines. A very high mass of air activated through a very small change of momentum is what the propellers do. So, typically a propeller would operate with air mass flow, which could be of the order of 30 to 40 times more than that of a jet engine of the same size. So, the propellers and the jet engines operate on same principle, but they use the air mass in different ways. This is a typical modern propeller. It has large propeller, as you can see here. The propeller body is much larger than the engine body. Okay, so, it is actually geared to use a large amount of air mass. On the other hand, a modern prop fan, as I mentioned, and we shall study this later afterwards, uses a propeller which is mounted at the rear of the engine, and you can see here two propellers. you can see here the propeller is still very big compared to the size of the engine. In the next class, we will have a look at a modern jet engine. We shall look at the various components of the jet engine, how they function, and finally, how they create thrust by using all these components together in a matched manner. So, that finally, we have a net change of momentum, which finally creates a thrust that makes an aircraft fly. And we shall cover the modern jet engines or various kinds of jet engines in the next class.